Okay, it's exactly 2 o'clock. Thank you very much for to everybody for being here today. A very special welcome to all of our participants. Thank you so much also to Sandra and Maarten. Thank you very much for taking the lead and putting this all together. So people are here to listen to you. So I hand over Sandra. Thank you very much. Once again, I hand over to you.
Thank you, Renee. Can everyone see my slides? I've just shared the
Perfect.
PowerPoint.
The front
Great.
page.
Yes, that's great. Thank you. So welcome everyone to the second session of our mini-school on monitoring biodiversity with data cubes. As I introduced myself last week, and I'm Sandra MacFadyen, and together with Maarten Trekels, we're going to take you through the concepts of data cubes and how it can transform the way that we monitor biodiversity. I'm not going to run through our whole introductions again. It's on the PowerPoint if you'd like to have a look. To give you a breakdown once again of the mini schools themselves, we've already gone through session 1, where we had a brief introduction to biodiversity and data cubes. We looked at sources of biodiversity data and data standards, and then the FAIR data publishing principles. Now, in preparation for this session, I asked everyone to please set up free accounts, the Google Earth Engine, the Colab, and the GBIF accounts. The website, the YouTube channel for NITheCS has already got that session uploaded. So if you want to go back and recap on that, you can click on that link. And today we will be looking at session 3, and Maarten is going to run that for us. We'll be looking at building data cubes with GBIF. So that's the Global Biodiversity Information Facility. We're going to give an introduction to that as well as the data therein. And then Maarten will take you through a hands-on guide on getting started with biodiversity and data cubes. Then next week we'll go into session 3, which I'll be running, looking at ecological modeling with data cubes. There you'll also be able to create your own data cubes using GBIF, Google Colab, and Earth Engine. And at the end of the day, you'll be able to create your own interactive maps, and you'll be able to do some basic analysis where you can relate species diversity, for example, to different environmental variables. Then the last session, we will be focusing more on open science, and we're going to look at how you disseminate the results, different platforms like GitHub and Zenodo, how you can use those to share your data, and we'll end off with a brief questionnaire on what you would like to see in the next session. As you'll see from the outline, we're repeating things quite a lot because we'd like to make sure that everyone's following correctly and that you'll be able to go on your own once the mini school's over. I think as Maarten also said previously, if you have any questions, our emails are on the system, so please email us if you're going to use your own data. As we go through the practical sessions, please do so and we can help you. I'll be on the chat today. Maarten will be running the show. So if you have any questions, please just put it in there and I will answer you. As I said, we needed to have these accounts set up. So I'll post them in the link now if you want to quickly do it, if you haven't done so already. And then I'm going to hand over to Maarten, who will take you through this hands-on session.
Thank you very much, Sandra. I will start sharing my screen and I will go through this lecture as much as possible without using the slides and make it as interactive as possible. If you have questions during the presentations, please put them in the chat. Then we can actually try to answer them as live as possible while we are running through all of the codes. I will start sharing my screen. on. Okay, you should be able to see my desktop now. Let me see that I can put the control somewhere else. First, let me introduce a little bit the coding environments. And while I'm going through the very basics of GBIF data and how to look at GBIF data, because we still need to ensure that we understand how the data looks like. If you didn't set up the accounts yet, please try to do it now. We are going to use Google Colab and Google Earth Engine. Especially what you need to ensure is that you have the Jupyter notebook I'll be using, which is on the GitHub repository. Sandra will put the link into the slides. There is a button on top of this Jupyter notebook, which says Open in Colab. Normally, with your free account, it should open immediately the notebook in Google Colab. The only thing we should not forget is that we are going to use Google Earth Engine, and for that you need to connect the Colab notebook to a Google project, which also is free, so you don't have to worry, you will not have any hidden costs. In order to do that, you have to actually go to console.cloud.google.com, and then you will see here on the top left the names of the projects that you have. If you click on this button, you will see here a list of projects or organizations that you are part of in Google. If you don't have a project yet in this list, please create a new project here. Important in the project is that you have to enable Google Earth Engine for that project. How do you do that? You can go into the overview here in APIs and services, enabled APIs. And then if you are lucky, at least, and if it doesn't take too much time, you would see here all the APIs that are enabled for this specific project, and you have to see Google Earth Engine in that list. If that's not the case, please here on the top enable APIs and select Google Earth Engine as one of the APIs you want to use in your project. So this is just a quick overview. If anyone has problems with this setup, please let us know. Then we can discuss and see where it goes wrong. But that's the very basics that you need. And at least for your project, the one thing you need in your Google Colab notebook is this ID. So next to your project name that you choose yourself, there should be an ID. That ID we will need later in the presentation when we start running the Google Colab notebook. Okay. Just for your information, I'm not going to use the Google Earth Engine editor, but if you go to the Google Earth Engine website, you will see a lot of things here, among which data sets you can find on Google Earth Engine, which is very interesting to see what kind of data we can be using. And Sandra will go into this more in detail in the next lecture. But also, if you explore the data, you can actually see how to use it in Google Earth Engine editor itself by clicking on the code editor, opening code editor. I'm not going to go there now, but know that this is possible as well to do it straight into Google Earth Engine. Okay, back to the basics. What we want to do today is we want to create data cubes out of GBIF data. But before we can do that, we do have to understand a little bit how GBIF looks like and how this is working. And if we look at GBIF and you go to the website gbif.org, and I advise you to just follow along if your internet connection allows it. It's easier just to click around and to see how this looks like. You can see on the entry page that you have a few views on GBIF: the occurrences, the species, the dataset, the publishers, and the resources. I'm not going to go to all of these views, but to give an example, if you click on the dataset view, what you will get here is a whole list of datasets which are available on GBIF or that are shared on GBIF. For example, the dataset from eBird, which is a citizen science platform, or there are checklists datasets like the Catalog of Life, which is just a list of all species names. There are other taxonomy, the iNaturalist dataset. As I explained last week, GBIF is really an aggregator and tries to collect all these datasets and make them interoperable with each other. And so if you are interested in one specific dataset, it might be interesting to go into this dataset view and click on one to get basic information about this dataset. Another view is on the species. This is basically giving you an overview of all the GBIF, of the taxonomy that is used within GBIF. And so you can browse through the taxonomy of what is available on GBIF. For example, if you go and look at the plants, you can see which kind of families are in there, which kind of phyla are in there. You can get some metrics out of this, which is also quite interesting to see. If you click on the metrics button, you can get an overview on how the taxonomy looks like. You can see in what months most of the plant data, and because I clicked on plants here, are collected. Where you already, I think we mentioned this last time as well, where you can already see that there is a big bias towards the global north on observations, because most of the plant data was collected in the spring and summer months in the global north, where the most occurrences are situated. So you can see that most of the plant occurrences are coming from France and so on. So this is kind of interesting how this evolved in time, and you can clearly see, for example, the onset of citizen science in the early 2000s, which exponentially exploded the whole observations within GBIF. But the one that we are actually interested in today is the occurrence view. If you go into occurrence, an occurrence is just one single observation or one single instance of a species at a certain time in a certain place. So if you click on this occurrence dataset, you will get, and I didn't apply any filters yet, every single observation of a species that is recorded within GBIF. And you get already some basic metadata that you can see, for example, in what country, what coordinates, at what date, and so on. If you click on a single one, and I'm going to try to use one where I'm sure that there is an image attached to it, so I can take, for example, the iNaturalist data. Okay, so apparently my filters are not happening. Okay, let me just take a random one. It happens sometimes that the filtering is not really working as it should be. But for example, this is a red fox record in Great Britain. It gives you a little map, if there are coordinates attached to this, where it can be found, and all the data which is recorded with that record. So for example, In the event section, you see at what date it was recorded. You can see on the occurrence itself, there are some additional data available. For example, in this case, it was the observation of an adult fox. And then taxonomy, what is the taxonomic status? Location, if the location is known. Okay, so that's actually important because all of these metadata fields or data fields on an observation can be used to filter your data. So if we go back to the whole of the occurrences, if I, for example, want to filter out all the occurrences from a specific country, and let's take South Africa as an example, you can use it as one of the filters, and you can see that I get all of the South African records. You can display them if there are images on each of the specimens. You will see them in the gallery. It's still a little bit much of the occurrences, so it might load a bit slow. You could also visualize them on a map, and you see that there are still quite some errors on this. And this is something you have to take into account when you are looking at GBIF data, that data cleaning is, in principle, still an essential step in the whole process. One of the big biases that you can, for example, see and that you have to really take into account is that at this point here in the center of the image, and maybe I should make my screen a bit bigger to make it clearer, is that at this 0, point where the meridian and the equator are crossing each other, you have a lot of observations. These are basically mistakes. These are people that didn't put 0 coordinates into their occurrence, or for some reason that they ended up there. You can also see occurrences that have coordinates which are not based in South Africa. So maybe someone indicated the country, but indicated it wrongly, which is also a possibility. But you can see that most of the occurrences are in the area that you expect them to be. You can get a list view that maybe, let's see, yeah, this is, for example, the gallery view. It's working now. So most of these are probably from iNaturalist, people taking images of the things, but there could also be natural history specimens. You can get an overview on the taxonomy of everything which is recorded in South Africa. So which species is the one which is the most recorded, and some other metrics that you can see. So here you can see when most of the recordings are happening. Most of them are human observations, but there are also some preserved specimens and material samples. What kind of issues that are attached to this specimen? So GBIF already has a mechanism in place that looks at potential issues. For example, a country that is derived from the coordinates, or some mismatches that are happening within the data. So you can get already a view of what possibly can be wrong. And also, what are the years that most of the specimens are collected, and which are the data sets they are coming from. So that's also something to keep in mind, that all of these data is coming from many different data sets around. Okay. If you look here on the left-hand side, you can see actually already a few things where you can filter on, and which I showed. For example, if you filter on plants here and look at the table again, we get the table. But there are many more filters you can choose of. And if you look in the All Filters tab, you can see a lot of the data fields that are stored within GBIF that you can use as a filter to get whatever you want in your data set. So that's also something to keep in mind, that not everything which is displayed in the graphical user interface, there are some fields in the back that you can also use for filtering, and that might be important if you want to filter out certain data sets or taxa or whatever. So, and all of these fields we can also later use to get our data itself. So I filtered out about still a bit much of the specimens. I will go back and filter a bit less, that we have a bit less specimens. Let me see, let me go to the more complex filters, and then I can, for example, only filter out things that are coming out of natural history collections, so preserved specimens. What you can do is go into the basis of record field and select preserved specimens. And what we will get here now are only those that are in a natural history collection or that are flagged as being a preserved specimen. In principle, if you go into the gallery, you will see that you will then get images of specimens that are from a collection. So now we already have a little bit less results. Oh, why is this happening? Okay, my filters seem to be gone. Let me go back and filter again. Like this. But then we have this list of specimens or list of occurrences that we can find into the GBIF dataset. If we want to do more analysis on this, we can download this data. You can download it in a simple format, in a simple CSV format, but there are many more other options that are available. And if you look here on the right-hand side, you have the download button. You can click on this, and then you see the different formats that you can use to download your data. As a simple CSV, so that you can import it in Excel and do your analysis in Excel. This is not the preferred way to do it, and I would not advise you to do. As a Darwin Core archive, a Darwin Core archive is basically a zip file containing multiple CSV or comma-separated value files that include the occurrences, but also the taxonomy, information on the images, and so on. This is the most complete data. So if you want the most complete data of all, you go into the Darwin Core archive, you get all the single occurrences that you can find in your data set in all detail. So both the links to the multimedia, the coordinates, the raw data, but also the interpreted data, which is the data which is corrected by GBIF itself. For this lecture, we are actually mainly interested in this last format, which is the cube format. So we can, within the GBIF platform, already create data cubes where we start aggregating data at a certain level. And let's just try this out. If we want to download a cube, we can aggregate these occurrences according to taxonomic, temporal, or spatial properties. And this is just a way to reduce the amount of data. You can see if we go back here, if I download from this dataset the raw Darwin Core archive, I end up with a dataset of about 6 GB big with single occurrences that are maybe having some issues or that I still need to do data cleaning after I download the Darwin Core archive, because the Darwin Core archive contains the full list that we've seen with all the potential errors included. Or we go into this cube format where we are already going to implement some logic to aggregate them according to a specific logic. And just through the different steps you can take, for example, what are the dimensions of our data cube? So the most simple data cube is the one of the essential biodiversity variables, which is taxonomic at one axis, temporal at the other axis, and spatial at the third axis. In the taxonomic dimension, you can still choose at which level you want to aggregate. Do I want to aggregate them all at the species level, which means that I have individual species at that axis? Or do I want to already aggregate them to genera, families, classes, even kingdoms? So you can actually choose in this drop-down list at which level you want to do the aggregation. And I think for most cases, the species is the most interesting one, and you can track higher taxonomies later, so I can show that later. Then there is the temporal dimension. That means at what time scale are we going to aggregate the data together? Do I want to count all the occurrences of a species within a full year? Or do I want finer grained data? So collect them at every month. And so count if I have, for example, the red fox species, how many of the occurrences are there at a specific location within that month? So that's already a reduction. I think that's really depending on what kind of analysis you want to perform. Sometimes you want it over a full year, sometimes monthly. In rare cases, you want daily data. Let's now, for the sake of demonstration, take year and month. So we will aggregate them on a monthly basis. And then we can still aggregate them spatially. And this is an important step to take into account, because if you have citizen science data, those data is often quite accurate because it's recorded with a cell phone with GPS coordinates attached to it. So you can be pretty sure that this observation was at that location, although that's also not fully correct, because if you are collecting bird data, for example, you actually are recording your own position and not the position of the bird. So there is some uncertainty of where a specific observation was taken. And especially if you go and look at historical data or legacy data, where, for example, the position is derived from a label on a specimen which just gave you the city where this recording was done, you have a big uncertainty on this. And so you want to deal with this uncertainty, not only the uncertainty, but also the fact that biodiversity data is rather sparse. So you don't have very detailed information of all species at point locations as you have, for example, with remote sensing. So you might consider in aggregating these observations together in a spatial grid. The interface actually allows you to select the grid size on which you want to aggregate. In Europe, you can use the EEA grid, and then the other grid systems that you have are more globally accepted. For example, the extended quarter degree grid cells. I will take that one as an example. And then you can see what are the sizes of cells that you can use. And also this depends a little bit on your research question on how big you want to make these cells in your data set. So for example, you can aggregate all data in 14 kilometer square grid cells. And then you take level 4. The last parameter you can choose has to do with this uncertainty. And that's something you really, and when we go to the Jupyter Notebook, I will try to visualize this a little bit. If you have an observation with a big uncertainty, that means that this observation could everywhere be occurred in that uncertainty circle around that observation. So you cannot be sure that the coordinates that are given to that observation are really the coordinates of that thing. There is some uncertainty around. Now you can make a choice. Either you say, okay, I'm fine to go with that coordinate and then do all my calculations accordingly, with the high risk that, for example, a lot of observations will be centered around some kind of centroid in a city or in a province or even in a country. The other thing you can do is, okay, I know with the uncertainty that observation is somewhere in that uncertainty circle, so I can randomly assign this occurrence to any grid cell that falls into that uncertainty circle. So you can do that, and then you select yes, or you cannot do that. If you select no, then you will just use the specific coordinate of that occurrence. Then you can choose to count occurrences at higher taxonomic levels. That might be interesting to normalize your data. I will unselect a few that I'm not interested in now. You can include the minimum coordinate uncertainty as a parameter just to know or to have an ID on your data quality. Same for the temporal uncertainty. And then a special step here is that you can impose additional quality to your data. So I want to remove all the records with geospatial issues because I want to make sure that every occurrence I use doesn't have any issues attached to it. For example, if it's in country South Africa, but the point itself is in Mozambique, I don't want that record in my data set because I know that there is something wrong with that data. And I also want, for example, to remove all the records which are at the country centroid, because those are just data where they put a country and didn't specify the location. Although you can say with the randomization, this will filter out a little bit, so you can unselect that if you want. And then you can press download. If I now will press download, it will start the download. It will start generating the data. And then when the data is ready, I will receive an email from GBIF saying, oh, your data is ready, come and select it. Where can you then download your data? If you go to your user name here on the right-hand side, you can see here downloads. And then you can have a list of all the downloads that you ever requested from GBIF. So in this case, for example, if it says SQL TSV zip file, that's one that you made with the DataCube interface. If it's a Darwin Core archive, it will also say it here. And then you can show it and basically download it as a zip file on your PC. Okay, good. This is the simple graphical user interface. Of course, we can do much more with this data, or we can do much more with this interface and the SQL interface. So let's go back a little bit here. I'm not gonna go over the whole process again, but if we click download and we want a cube, we select, for example, that now I want it at this taxonomic level, at this aggregation, in a very big grid cell. I want to randomize everything, but I want to include additional parameters into this SQL query. In that case, you can actually make your query or the thing you request from GBIF as complex as you really want yourself. And if you are very familiar with SQL language, you can actually here at the bottom click on Edit as SQL. And then you can see in the back what is running on the GBIF infrastructure. So basically, this is the SQL query that will generate your cube. If this is what you want, fine, you can press download. But if you want to have additional information from GBIF, you can do that. And if you click here on Start Editing, you see that you can now start editing the SQL query yourself. For example, I want to know how many different people were observing these occurrences within a cell. Then I can just add an additional statement in the SQL saying, for example, here, I want to count the distinct recorded by. That's one of these data fields in GBIF. And I want to call that parameter, for example, distinct observers. Just by adding this simple line into your SQL statement, you will have an additional dimension in your data cube that counts how many distinct observers there are of a specific species at a specific time window at a specific grid cell. And this can be interesting for many reasons. For example, this can be a sort of normalization factor if you want. And you can actually send SQL queries that count the number of species over a certain time period in a certain area. So you can make a link to the documentation website, so you can see what kind of supported functions there are to include into your SQL query. So if you are really interested into this, please go to the technical documents of GBIF, and you can start building your own queries to get information out. You can even send those queries, if you save it in a JSON format, over the GBIF API. And also there for the API downloads, there is a lot of information available on how to do that. I'm not going to go into detail in this session. If you have questions around that, please let me know. And also on how to use the GBIF API, there is a lot of information here. There is the beginner's guide, but then there are also R packages and Python packages that give you an interface to this GBIF API. And I think that's kind of the point where we can start doing a real demo and not just talking about this. So if we go into the Jupyter notebook that we shared to you, you can we can start playing around. For example, I installed in this Jupyter notebook the PyGBIF package. It's Python, so but it's very similar for R. So if you want to run this in R, please, you can. So I already pre-installed it, so you will see if you run this for the first time, it will install the PyGBIF package, and I will write this a little bit. I will import some other packages that I need for my demo. I will come to the Earth engine later, but here at least there is a way to access the GBIF API through PyGBIF. I always forget to make my screen a little bit bigger, so please shout if it's too small. So for example, here I use the PyGBIF package where I import the occurrence view. So you can look at occurrences, but you can also look at data sets. You can look at species. So you can use whatever view. And then I search for occurrences of a specific taxon, but I use the species key within GBIF, and I limit it to 10. If you run this script and you print the results of it, you will see, at least in this case, 10 occurrences that are downloaded from GBIF with their dates, for example, and all the data which you can find in GBIF. So that's the way how you can access the data through PyGBIF. When you select a cube format or look at the cube format, you will actually end up in this kind of format. So if we can mount just one of the cubes. So in this case, I load a data cube which has data from South Africa in a CSV file. I didn't do anything very specific, so this is a regular download format. It takes a little bit of time to load the data, but when you have this data, you can visualize it. It takes a bit longer than I expected. But you will see that in this case, you will get a CSV file with the different access that you defined in your download. So in this case, it will be species, grid cell, and time. And I think I aggregated this data at a monthly basis. By the way, this is also interesting in later projects. If you want to use Google Colab and load your data, oh, it's loaded, so I can print the data to show you. So for example, this is a data frame containing the year-month axis, the grid cell code, and then all the other things that I requested from my GBIF download. If I added some exemplar data on the GitHub website. Interesting for you if you want to easily access this data from your Google Drive. You can put any file that you want on Google Drive and mount that drive. If you do this, drive.mount content drive, you will see here on the left-hand side this file icon. If you open that, you can actually see what's on your drive. So if you open this, you can see your Google Drive. For example, the shared drives are the ones that I'm using to share data. You can see which files are there. You go to the mini-school folder, the demo data, and you will see all the files that you put on your Google Drive. That's an easy way to access your files, and that doesn't include too much interoperability issues. So it's easy to get to your data. But you can, this is in shared drives, but you can also share it on your own Google Drive and make the link here to that where your file is located. Of course, this doesn't provide you a lot of geospatial information. You only get the grid cell code. So you actually have to match that grid cell code to a known geometry. Since that takes a little bit of time to run, I will not go through it, but you can read it into the Google Colab notebook if you want. And if you want to run it, you have to find a geopackage file that contains your grid and then merge the two data frames. But you can also load your data directly as Parquet files. So if you have a grid matched to your data, you can save it as a Parquet file, and these Parquet files are easily loadable in the, as geodata frames. So if you do that here, for example, I mount a drive and I read in the GeoParquet files, and those two files are actually available on the GitHub repository. So if you want to play around with those two files, you just have to place them into your Google Drive and make sure that this link is correct. And then you can filter on a specific species. I took just the species key here, which is an acacia species. And then I didn't add that in the Colab notebook, but you can easily add code blocks here and have a look at how this now looks like. So if you look on how this data frame looks, you get, again, kingdom key. It's not the best format to show it, but at least you can see that now it has an additional column which contains the geometry. So it's containing a polygon that corresponds to this specific cell code, which makes it easy for plotting. This is already one step. Now let's go into the visualization of these data cubes. For that, I will use the Google Earth Engine, and I will go back a bit to the section that I left out in the beginning. Here I load some Earth Engine data. To do that, you have to authenticate. I did it already before this session just to make sure that I don't have too many delays. But when you run this one and there is this ee.authenticate, it will open a pop-up window saying that you have to allow your Google to connect with Earth Engine. And you have here to specify the project that you're using. So that's the ID that I showed you when you create a new Google project. If you use this ID, which is my project, it will not work. You have to use one that is connected to your own Google account. And then you can select what kind of layers you want to visualize. You have the Landsat data, Sentinel data, but also data on the world data of protected areas. And all of these data layers that you can use, you can find in the catalog of Earth Engine. So if you go to Google Earth Engine and look into data sets, you can find all the information on where you can find all of these data sets. In this case, I use Sentinel data. I will not go over the details, but I will use Sentinel data and I clip it on one of the protected areas just to make my data set a little bit smaller. And then once you run this, you can start the visualization. So I go down a little bit again. I have to convert my geodata frame that I had from my GBIF cube into feature collections. That's a specific thing from Google to visualize this. So what I did here, and that's I forgot to mention, is the two files I show you here are, one file is containing the data cube. The other file is actually containing the pure occurrences, the ones that are that were used to derive the cubes, just to give you a visual idea on how this algorithm is working. And I want to visualize them both the point data and the cube data. And then there is a specific way to call the maps of Google Earth Engine into the Google Colab, at least the Python interface, which is GEmap. So I create a map with a certain size, which is at a certain zoom level with some visualization parameters. In this case, I use the RGB bands in the Sentinel layers. I add this layer to the map, but I also add the cubes and the point data. And what you will end up if you run this code is this. So basically what you have here are the data cubes, which are the ones which are in red, filtered on one specific species, of course, and then the point data that are associated to it. And what you can see here is that each cell has some points assigned to a specific location. So you can see that there are more points into this cell than there are in this cell. So number of occurrences to this cube will be higher than at this one. But there is some randomization going on. So some of these points might be assigned to this cube. Other points might be assigned to the other cube. And this is purely a way of aggregating. Because of the fact that you only have a limited set of observations, you actually don't know for sure that it's only occurring there. So this is somehow by aggregating that you get a clearer picture or a more basic picture on how the biodiversity looks like. Depending on your application, you can make your cell sizes bigger or smaller. It also depends a little bit on how much data you have on a specific species, on how big you can make your cells to still make sense out of your data. And then to make this data cubes interoperable with a remote sensing layer, you saw in my script that I added the Sentinel data to this. So if I just click on the Sentinel data, you can see that you can overlay Sentinel data to this to the grids, and then try to make sense out of the interoperability between the Sentinel layers and the grid cells that are in that you collected in GBIF. So this is somehow a basic overview of what you can do with this data cubes. I mainly focus now on the going from a CSV transformed into a data frame, either not in a GeoParquet format. Of course, you can look at or you can have these data cubes in different kind of formats as well. And so if you ever hear of GeoBon and the EBV data portal, you can actually see that also NetCDF is one of these data formats where you can find data cubes. And I've put a link into the Jupyter Notebook if you want to have a look. And I've put a few lines of code on how to visualize data from a NetCDF file. And so you end up with a similar type of output where you get a map with the distribution of a species in a certain grid size. So in this case, it was 10 by 10 kilometer grid. If you want to go to this, please go ahead. The notebook is there and you can start playing around with different kind of data formats. I put one exemplar NetCDF file on the GitHub repository, but you can find many more on the GeoBon data portal. And with that, I actually would like to open for questions or things that you want to see answers of. I also want to invite you to go and have a look at this Jupyter Notebook and start playing around. One additional thing is you don't have to stick to Google Colab to play around with it. If you are more familiar with, for example, data from Microsoft Planetary Computer, also there you can load in these Parquet files and start playing around. You can contact me if you want more information on that. So with that, I want to finish and see if there are any questions that you want to see answered right now. I didn't follow on the chat, so I don't know if there is anything particular that people want to see answered now. Things that are unclear. I don't know whether we can unmute someone if there is some questions.
Yeah, sure. Please, if you have a question, please just raise your hand, type something in the chat, and we can give you the opportunity to ask your question. So please feel very welcome.
Also, if you have any questions between now and the next lecture, don't hesitate to contact me or Sandra. We can have a look at it. Maybe we can come back to that question at the beginning of next session, because not every question I can answer just on the spot. But at least if there is something unclear of what I said today, go ahead. My main message is start playing around with these tools. The tools are there, they are available, they are open, so you can start playing around, modify the scripts that I prepared for you, and try out different things. Stop sharing. Let me see if I can.
Hey, if anybody has any questions, please feel very welcome. put it in the chat, put up your hand.
I think many people have had some trouble with the Google Earth Engine API and initializing it with the project. So just to let people know, I will be going over this again next week, and I'll take it a bit slower so that everyone can follow. I see Natalie has a question.
Thanks. Mine is more towards the map that was just shown. I just want some clarity. Did it only draw the data cubes, or down towards the south, it showed some topographical things as well? So I just want to make sure, what did the code write and what was sort of background data? Thanks.
Okay, I can show that. Let me go back to my Jupyter notebook. So, and then share my screen. So actually what I've shown here is you have an OpenStreetMap background anyway, which comes standard with Google if you use the Google GE map. So that's standard. You have the red structures, which are the data cubes. So if I can unselect those, and you can see those are the data cubes generated. The blue points are the point data. So this is what was used as base data to generate those cubes. So I can, if I remove them, you should just purely see the data points. And then what I wanted to show was the interoperability between, for example, things that are coming from Sentinel data. And in this case, I just selected Table Mountain National Park. I clipped the data on that. So if I remove that, you can see that those data are coming from Sentinel. So the structure that you see here are basically just the Sentinel data, and there is a bit of a delay on visualizing it. So this is data which is coming from Google Earth Engine itself, from one of those data sets. And you can change this. So basically, if you go to the top of my script, you can see here that there are a few data sets that you can use, but you can use all of them which are in Google Earth. And then I filtered the Sentinel data set first on South Africa, but then I also clipped it on one of the protected areas, just to make it a bit faster. Does that answer the question?
Yes, that one is specifically what I was wondering about. Thank you.
Liam Davids, I see that Sandra has answered you. Does that answer your question? And I see also Jess Provost was still getting an error. Jess, are you sorted, or do you want to maybe take it offline and see if you can get that fixed? Liam, are you sorted? Okay, Jess is sorted. Liam, are you sorted as well? Yeah, you've got your answer. Anybody else? Okay, I think that then we can then wrap it up today. Let me thank Sandra and Maarten very much for this. Thank you so much. Thank you for your effort in preparing this. We really appreciate it. And if anybody has anything that comes up, please feel free to contact us, and we'd be more than happy to assist. Thank you so much again, Sandra. Thank you, Maarten, and thank you to everybody that attended today. All the best. See you next week.
Thank you. Thank you, Renee. I just put on one last slide just to advertise the micro school that's happening on Friday. It's not specific to today's session. It's actually the last session, but it is on Friday the 13th. I've just put the link there if you want to register. It's a rerun from last year's micro school as well. So I put the recording on there. So if you'd like to attend, do that.
Thank you. Thank you for doing that. That is excellent. Brilliant. Thank you. Okay.
All right. Thanks, everyone.
Thanks, everyone.
Thank
Take care.
you.
All the best. See you next week.
See you next week. Cheers.
very much. Cheers. Bye-bye.